Hello guys. All right, so today we're going to talk about function notation. A function notation is when a function can be written as an equation. The symbol f of x replaces y. So f of x is still y. That's what y is, okay? It is y. Okay, so when it replaces it from x comma y to x of f of x. Okay, because f of x is y. Okay, replacing y with f of x is called writing in a function in function notation. That's all it is. Okay, and today we can overcomplicate it or we can simplify it. So today, what we're going to do is we're going to remember that if we are given a number inside of the parentheses, f of -3, this means -3 is your input and you plug it in for x. Okay, so for example, we have f of x equals 2x minus 3. Find the following. All right, so this means I'm going to take my equation 2x minus 3. I'm going to plug in -2 there. It tells me f of -2. So this x turned into a -2, meaning wherever there's an x, I plug in -2. Okay, so it's 2 times -2 minus 3. Your calculator, if you put it in correctly, should solve this. So in your calculator, you're going to put 2 parentheses, -2 parentheses, minus 3. Okay, so when you do that, -2 times 2 is -4 minus 3. So f of -2 will get us a -7. Well, when we get this answer right here, we're then going to write it in an ordered pair. Okay, so our ordered pair is whatever we plugged in for x, so -2, and then whatever we got for our answer, that is our y, so -7. Your input, we talked about this on our last notes, your input is always x, so what we plug in. Your output is always your y, so what we get out of what we plug in is our output, it's y. So that's why -7 is our y coordinate. All right, so f of 7. So f of 7, so 2 times 7 minus 3. 2 times 7 is 14 minus 3. So f of 7 is whatever 14 minus 3 is, which is 11. This is our answer, but we're going to write it in an ordered pair. So then we get 7, 11, because our input was 7 and we got out 11. All right, I want you to try C. Okay, try this yourself. And then check your answers with a copy of notes. All right, now we're going to go into K of X. So K of X, so it tells us K of X is -7x plus 1. Find the following. K of 0. So again, wherever there's an x, I'm going to plug in a 0. So we have -7 times 0 plus 1. -7 times 0 is 0. 0 plus 1 will get us K of 0 will be 1. And our ordered pair will be 0, 1. All right. I want you to try E and F on your own. Okay. And then the answers will be on the copy of notes. And I'm also going to put them in the description of this YouTube video. All right. Sometimes there will be multiple x's in an equation. Multiple x's. When that happens, when this occurs, simply replace both values with the same x. Okay, so it's just one more step, okay? Not even one more step. It's just one more way, one more spot you have to put x. So our first one, if h of x is x squared minus 3, x plus 5. Find the following. So we have h of negative 3, so I'm going to plug in a negative 3 everywhere there's an x. So I have x squared, so negative 3x minus 3x, so negative 3 plus 5. So again, I always use parentheses because it lets me know what I plugged in and making sure I plugged it in correctly. So negative 3 squared is a positive 9. So negative 3 times negative 3. Again, another negative 3 times negative 3. Take the sign with it. When we do that, we get a positive 9. So I'm going to do add 9. And then we add on the 5 on the end. 9 plus 9 is 18. 18 plus 5 will get us 23. So h of negative 3 gets us 23. Then we make our coordinate or ordered pair. So negative 3, comma 23. All right. Again, I'm going to do this one and then y'all are going to do the next one. Okay. So again, h of 5. So I'm going to plug in 5 wherever there's an x. Okay. So we have 5 squared minus 3 times 5 plus 5. 5 times 5 is 25. Negative 3 times 5 is a negative 15 plus 5. Now we just add and subtract from left to right. 25 minus 15 is 10. 10 plus 5 is 15. So h of 5 gets us 15. And our ordered pair is 5, comma 15. I want you guys to try P of x. Okay, and the answers will be in the description and on the copy of notes. All right. So this one, f of x is 5x minus 3. Fill out the following tables of values. Okay, so these are the same thing. So here are inputs, what we're plugging in for the x, and then we're just going to write our outputs in this table right here. We're going to write our outputs here. Okay, so we have f of x, and our first x is negative 2, equals 5. We're going to plug in negative 2 to that x. So we have 5x minus 3, so 5 times negative 2 minus 3. So 5 times negative 2 is a negative 10. Negative 10 minus 3 is a negative 13. So negative 13 goes here. And then you're going to plot it. But this doesn't, negative 2, negative 13 does not fit on the graph. So the next one is f of negative 1. So we have 5 times negative 1 minus 3. So we have negative 5. 5 times negative 1 is negative 5 minus 3, which is a negative 8. So negative 8 goes under negative 1 because this was my input. Negative 1 was my input. And then negative 13 and negative 8 were my outputs so far. So now I can graph this one. So over here on the graph, I'm going to go to the left 1. Let's zoom in. Go to the left 1 and then go down 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, and then I'm going to do 0. So f of 0 equals 5 times 0 minus 3. I plugged in what it told me to plug in. My input was 0. So I plugged in 0 where there was an x. So 5 times 0 is 0. 0 minus 3 will get us a negative 3. That means my output is negative 3, and I got that output of negative 3 when I plugged in 0. So over here, we 0 and then negative 3. So go down 3. The reason I'm getting these coordinates is because when I plug in, remember our ordered pairs is -2, -13, -1, -8, and then 0, -3. All right, so I want you to finish this table out. So you're going to find f of 1, f of 2, and f of 3, and graph those, and you're going to check with my copy of notes to make sure that we graph those correctly. All right, using the table of values, find the following. So we have a table of values full of values, okay? All right, so it wants me to find f of -3. So when x is -3, what is the value of y? Because remember, it's f of x. This is our input. X is our input, okay? And when we input -3, it wants to know what the output is. Okay, so this means when x is -3, what is y? Or f of x, so this table right here. So when I'm looking at my inputs, my x's, okay, all right, I got to find -3. So -3 is here. So what is the value of my f of x, so y, when -3 is x? All right, so when f is -3, y equals 2. All right, let's do another one. So again, this means when x equals 20, because 20 is inside the parentheses of f of x, what is y? So I'm looking for 20 along the x. So here's 20. So when f of 20, y equals 0. All right, I want you to do C. D says f of -1. Okay, so that means when x equals -1, but is there a -1 on this table? No, okay. So our answer is in A because there is no -1, okay? All right, here's the kicker. Here's the little switcheroo right here, okay? So it says if f of x equals 9. So if we look at our table, we're looking for where f of x equals 9. So we're looking at this table right here. Like this one that's highlighted in yellow. Okay? So all of these are saying if f of x equals 0, if f of x equals 9, okay? This means when y equals 9, what is x? So now we're looking on the bottom row and we're looking for the number it gives us, so 9. So when f of x equals 9, x equals 2. So again, if f of x equals 4, so y equals 4, what is x? So I'm looking for 4 of the f of x table, a part of the table, okay? And I'm looking for 4. So when f of x is 4, it's 9 and it's 8. Okay, so x equals 8 and 9. So therefore, it's going to be 8, 4 and 9, 4. Okay, I want you to do G and H and see what you get. Instead of finding the value of a function at a given x value, you will be given the value of the function and asked to find the value of x. In these cases, replace the function notation and solve rather than the x. Okay, so here's what it means. So it says let f of x equals 2x minus 3. This is our function. Okay, no big deal. Been there, done that. But now it says if f of x equals 15. So this means right here, y equals 15. I have to plug in 15 for wherever there's an f of x. So f of x, so this means 15 equals 2x minus 3. And now I'm solving for x. So this means get x by itself. So we got to undo the addition or subtraction. So we're going to add 3 because it's subtracting 3. I'm left with 18 equals to x. And then I must divide by 2. So 9 equals x. So therefore, our ordered pair is 9, 15. Because this is what y equaled. Let's do another one. So it says, let G be 3x plus 2. And it tells us that G of x is equal to 11. Okay, so this means that y equals 11. So I got to plug this in here. So then it's 11 equals to 3x plus 2. And then now I'm finding x, so I must solve. So subtract 2. Remember, undo the addition or subtraction. We're left with 9 equals 3x. Then undo the addition or multiplication or division. So it's multiplying here, so I must divide by 3. So 3 equals x. And then our ordered pair is 3, 11. All right, I'm going to do one more just because I know how confusing this can get. Okay, so let W equal 3x plus minus 7, where W of x equals 14. So this means, again, y equals 14. So I'm going to plug in 14 here. If there was a number in this parentheses here, that's when I would plug in for x, but there isn't. It tells me that this whole thing equals a number, so I must plug that number in wherever there's a W of x. So then it's 14 equals 3x minus 7. Undo the addition or subtraction first. So 21 equals 3x. Then divide by the coefficient. So 7 equals x. So our ordered pair is 7, 14. So remember, if it's f of a number, so f of -2, you're going to plug in -2 for every x. If it's f of x equals 15, you're actually going to plug in 15 for y, then solve for x. Okay, so those are the two scenarios you're given. All right, so I hope this helps to kind of break everything down and expect to practice. Bye, guys.